Imagine a world where looking through a glass lens could condemn you to death, where questioning thousand-year-old truths would lead you straight to the fires of the Inquisition. In 1633, a 69-year-old man was dragged before the judges of the Holy Inquisition in Rome. His crime? Defending that the earth moved around the sun. This man was Galileo Galilei, and his story would forever change how humanity discovers truth. This is not just the history of science. It's the story of four rebels who risked everything to challenge the most feared power of their time. An intellectual conspiracy that destroyed 1,500 years of absolute certainties and planted the seeds of the revolution that still shapes our world. For 15 entire centuries, since the fall of the Roman Empire, Western knowledge lived under the absolute dominion of three unquestionable authorities. Aristotle, the Greek philosopher who had established the rules of nature more than 2,000 years ago. The Catholic Church, which transformed these ideas into sacred dogma protected by the Inquisition. And Ptolemy, who had mapped a cosmos with an immobile earth at the center of everything. It was a world where asking dangerous questions could cost your life, where Giordano Bruno was burned alive in 1600 for suggesting that other worlds existed beyond ours, where curiosity was heresy and direct observation an act of rebellion against God, where entire libraries were burned for containing dangerous knowledge, where scholars spent entire decades debating how many angels could dance on the head of a pin, but never dared question whether angels actually existed. But four extraordinary men decided that truth was worth more than their lives. The first rebel was born in Pisa in 1564. Galileo Galilei wasn't just a brilliant mathematician. He was a man obsessed with precision, tormented by the need to prove every statement through direct experience. As a child, he would spend hours observing the pendulum of Pisa's cathedral, timing its oscillations with the beats of his own heart. Son of a musician, Galileo had inherited the sharp ear to detect when something was out of tune, and the intellectual world of his time was completely off-key. His restless mind led him first to study medicine, then mathematics, always questioning, always testing. His colleagues considered him too stubborn, too dangerous. He asked questions no one wanted to hear. This obsession led him to the moment that would change his life forever. While everyone blindly believed that heavy objects fell faster because Aristotle had said so, Galileo had a terrible doubt. What if the great philosopher was wrong? In his improvised laboratory, using spheres of different materials rolling down inclined planes, he made a discovery that left him trembling with excitement and fear. All bodies fall with the same acceleration, regardless of their weight. A feather and a stone, in the absence of air, touch the ground at the same instant. It was more than a technical correction. It was a declaration of war against 2,000 years of Aristotelian authority. But it was in 1609 that Galileo crossed the line of no return. Dutch merchants brought a curious invention, the spyglass, a tube with lenses that made distant objects appear close. Galileo didn't just copy the design, he obsessively perfected it, creating telescopes that magnified up to 30 times. And then, on a cold January night, he did something no human being had ever done before. He pointed this instrument directly at the sky. What he saw through those lenses left him in shock. 4 small points of light danced around Jupiter, moons that clearly didn't orbit Earth. If Jupiter had its own satellites, then not all celestial bodies revolved around us. The geocentric model that supported all Christian cosmology had just collapsed. Venus showed phases like our moon, impossible if it was always between us and the sun. The moon itself revealed itself covered with craters and mountains. An imperfect world like ours, not the immaculate crystalline sphere that theology demanded. The Milky Way, which appeared as a nebulous band to the naked eye, exploded into thousands of individual stars through his lenses. The universe revealed itself to be infinitely more vast and complex than any medieval mind had dared imagine. Galileo documented everything meticulously, made precise drawings, measured angles and distances. Each observation was irrefutable evidence against the geocentric model, but he also knew that each discovery put him in mortal danger. Each discovery was a stab in the heart of the system that had governed Western thought for millennia. And Galileo knew that each observation brought him closer to the stake. While Galileo challenged the heavens in Italy, in distant Germany, another rebel waged an even lonelier battle. Johannes Kepler, born in 1571 to a poor and dysfunctional family, was a man haunted by mystical visions and obsessive mathematical calculations. Since childhood, he suffered from weak vision and trembling hands, defects that ironically made him unsuitable for direct astronomical observations, forcing him to become the greatest astronomical mathematician in history. Kepler survived a brutal childhood, lost several children, saw his mother accused of witchcraft, but amidst so much suffering, he maintained unshakable faith. God had written the universe in perfect mathematical language. But what language was that? The answer came when Kepler inherited the greatest scientific treasure of his time, the astronomical data of Tycho Brahe, 20 years of observations more precise than anything ever seen in history. Tycho died in 1601, bequeathing Kepler thousands of celestial measurements and a desperate request: find the order behind planetary chaos. Kepler began his journey convinced of a truth that seemed obvious. Planets should move in perfect circles. The circle was the most divine form, the only one worthy of the eternal heavens. For 8 torturous years, he struggled to force Mars's data to obey circular geometry. He came close, so close that any other mathematician would have declared victory. His model predicted Mars's positions with an error of only 8 arc minutes. Extraordinary precision for the time. But Kepler knew the obsessive quality of Tycho's observations. 8 arc minutes were 8 minutes too many. And then came the moment of genius that would define all future astronomy. He had the courage to abandon perfect circles and accept a form he considered geometrically inferior: the ellipse. When the calculations finally worked perfectly, Kepler wept, not tears of joy alone, but of profound relief after years of intellectual torture. Planetary orbits were ellipses, with the sun occupying one of the foci. It was simultaneously simpler and more beautiful than he had ever imagined. From this discovery were born his 3 immortal laws that we still use today to navigate in space. Planets move in ellipses, sweep equal areas in equal times, and there exists a precise mathematical relationship between distance and orbital period. Laws that work not just for Mars, but for all known planets. It was definitive proof that the cosmos obeyed universal mathematical rules. Kepler had found the mathematical music of the spheres, but he knew few could hear its melody. Observing and calculating weren't enough. It was necessary to create a method so that anyone could discover truth without depending on authorities. And here enter the last 2 revolutionaries. In England, Francis Bacon declared total war on what he called idols of the mind, the mental vices that prevent us from seeing reality. For Bacon, Aristotelian philosophy had become an intellectual prison, transforming the search for knowledge into an infinite game of commentaries on ancient texts. Bacon identified 4 enemies of truth: our natural prejudices as human beings, our personal distortions shaped by education, the confusions caused by imprecise language, and the philosophical systems that sell us invented worlds as if they were real. His solution was revolutionary: purge the mind of these vices and follow a rigorous experimental method. Observe systematically, record data in organized tables, compare results, and infer natural laws through analysis. It was the birth of the modern scientific method. Across the Channel in France, René Descartes attacked the problem from another angle. If Bacon was the master of observation, Descartes was the architect of systematic doubt. His strategy was radical: doubt absolutely everything until finding something impossible to question. After questioning the senses, the external world, even his own body, Descartes arrived at the only absolute certainty: cogito ergo sum, I think, therefore I am. The very act of doubting proved undeniably that there existed a thinking mind. But his most lasting contribution was uniting algebra and geometry in the coordinate system that revolutionized mathematics. By showing that any curve can be represented by an equation, Descartes transformed mathematics into the universal language of nature. And then happened the synthesis that changed the world forever. Newton took Galileo's telescope, Kepler's laws, Bacon's method, and Descartes' mathematics. and showed that the same force that makes an apple fall also keeps the moon in orbit. Universal gravitation was the key that opened all the secrets of the cosmos. Einstein took this vision even further, revealing that space and time themselves bend and stretch. And today, 400 years later, we use Kepler's laws to navigate rovers on Mars, build space telescopes following Galileo's optical principles, and our entire technological civilization exists because four men had the courage to question apparently unquestionable truths. When we look at the stars today, we no longer see the medieval universe of crystalline spheres and perfect circles. We see the infinitely complex and beautiful dance of reality in all its glory. All because Galileo preferred to look through a lens rather than accept ready-made truths. Because Kepler chose mathematical precision over geometric beauty. Because Bacon and Descartes created tools so that anyone could discover truth for themselves. They proved that the most revolutionary ideas are born not from accepting what we're told, but from having the courage to ask the most dangerous question of all. What if we're wrong? But this is only the first part of a much more fascinating and greater journey, because the revolution they courageously began would reveal even more extraordinary discoveries. If you want to know how an obscure English bookbinder discovered invisible forces that today connect the entire world through Wi-Fi and wireless communications, subscribe to the channel. In the next chapter, Light from Shadow, we'll discover how Michael Faraday transformed what seemed like useless scientific curiosity into the technology that defines our digital age. Think in the void.